Alles klar. So, herzlich willkommen. Ja, wunderbar. Welcome. It's the microservice lectures. It's 2021, the first week, January the 4th, and I welcome you to the 6th or 7th lecture in microservices. We have still some technical setup problems. But I hope that we will be able to record this lecture here to have it. I lost my Stream Deck, so I cannot switch between perspectives. We need to deal with this one, or I have to go to the desk and do it there. Welcome to Dualar. There are some people from there too. I need some more of your video pictures, please. That would be great in order to go into the details. So I still need to open my slides. So it's all a very complex start into the new year. Here we are. Great. And we are around somewhere here. Can you see that? Great. I hope you all have had nice holidays and Feliz Navidad. And so we go into the continuation of our lectures. Before Christmas, in the last lecture, I was not able to finish with the Cypress test to get it really running. Actually, it was nothing wrong with my implementation. The problem was with the Cypress tests. And, it was quite embarrassing. And I apologize for not really going into the details of this test. And therefore, I failed to get this right. I fixed it meanwhile. It took me quite half an hour of reading some more tutorial papers about Cypress to get the idea what's going wrong. And I will pick up this today at the end of the lecture. Before that, we need to talk more about these testing stuff. So we are testing so far the whole application as an end-to-end test with Cypress. This is quite okay for the React part of our application. So we can see how the user interface works and we can dig into the user interface. That's cool. However, the Cypress test has no access to the warehouse service. So we cannot go into that one easily here. And therefore, the test keeps limited. So if something is going wrong on the server side of our application, it just doesn't work. And the Cypress test cannot dig into it. And therefore, over the holidays, I extended our thing. I extended our thing and introduced Jest. Jest is another testing framework, and Jest is able to test our service, our backend, our warehouse server directly. And then you can actually dig into the Jest thing. What's going on the server side. So just to pick it up a little bit more, I'm missing the overview of the slides. I wanted to show again this picture here. So our whole architecture is, we have done the warehouse client almost complete. We have done large parts of the warehouse service, and we are going into the last element of these twos and to connect those twos. That's basically the point. And perhaps I should dig into this picture. No, let's stay with jest for now. So the point is, we need to do more testing of the server, and you need to go to the slides. Can you still go to the slides? You probably have it, and then you can follow this link, and then you will find how to install Jest. It's yarn ts jest supertest is something you need to, and perhaps you really need to install at symbol types of Jest. It tells you if it's missing that. That is necessary to be able to import the Jest things in TypeScript and these kinds of things. And then you need to add something to your package JSON file. Basically, you copy this part of the whole thing here and you put it into your application. So I need to start my development environment. Oh, it's already here. So there's this package JSON. Can you see that? Oh, it's a little better. There's this package JSON here, which has some information about things. There's this script sections, you recall that one, where we can actually start things. I have actually changed some things on that, but I'm not sure which ones. I actually added more things. So the start script has changed to TS Node. This is Node Express after all. So usually it was before that it was just Node, or our TS Node is able to execute TypeScript directly. So we do not need to translate TypeScript to JavaScript and then start Node on it, but we can do it directly. And that's facilitating debugging and other stuff. Therefore, I use that one. And there is TS Dev 2, which is TS Node dash or minus dev, which is the development mode of TS Node, which is able to do this incrementally. So if you change something to your TypeScript code, the dev thing is going to update itself automatically. I'm not sure whether I'm actually using it. I was doing a lot of experiments over the holidays in order to cover up the problem with Cypress and the Jest thing and all these kinds, and did a lot of restructuring to mitigate with this embarrassing thing that during the lecture I was not able to complete the whole functionality and to get the tests running. So to run Jest, you need to add this part to your package.json file. It tells Jest where to find the tests, which is here. It's a directory which is this __test __, and there you put your tests in. And some other stuff, I have no idea why they need that. So let's have a look at the __ test thing. This is here in the, come on. So we have the warehouse, the shop, and the server for the warehouse. And in the directory or project for the server of the warehouse, in the source directory, I have added this test things here. It's actually installed automatically, I think, when you do this John install. And there I run the test. And I have a test for user management. And the convention is the name of the test, .test.ts. So the syntax for this is pretty similar to what you are used to in Cypress. So this describe, and then there are a lot of these it things. It's actually called a super test if I get it right. And so we use the same kind of testing that we use with Cypress. So we give a describe, say, okay, that's what we are testing. Then we give a number of it things, and we give for each of these testing steps a description, what we are testing for. Can you actually read that, guys? Could you raise your hands? You can read that? Dwala, you can read that? So Dwala is a little bit late, probably. Can you, Gael, can you actually see that? Can you read the program code? Yeah. Otherwise, they can have it later in the video on YouTube. So what we do is app is actually our express service, and then we do an app.get and ask for /, and that is the same as our application or a browser would call the local host and then the port number and then / to get the initial thing. So, and we expect that it is answering to us with welcome audience to the WASP server. And so actually we do this request. So this is an operation provided by Jest. You give it the express service you would like to test, and then you do an operation on that one, and then you do an await. That's an important thing here, because this is something that needs time, and in JavaScript or Node, all the things that need time are usually run in the background. So actually the Node Express thing has a kind of event loop, and we need to talk about this, where it is going to, well, does a loop forever, and then it has a list of tasks, and it executes the first task until it runs to something that needs a lot of time. So this get operation here takes a lot of time, and therefore it creates a new task object, puts it into its list of to-dos, and then continues with the task at hand. Well, actually, then it says, okay, no. Here it says, oh, please wait for that task that you have just created to finish. Then this event loop will actually drop the current task and pick another task from its to-do list. And at some time, it will actually then pick this request task, execute it, create the result, and put it and write it back to a so-called promise. A promise is actually, a place, a card, a piece of paper, a note, where you agree on when you do this call that later on the result will be written on that piece of paper. And so once this request has been handled, the result is filled onto this promise note or this little post-it or whatever it is. And so the event loop continues. And when this request pass has actually finished, this task card is go away. And at a certain point of time, the task for executing this thing here is revisited. And then it says, oh, look, the thing I'm waiting for, it has been delivered. And then it actually continues. So this await stops the execution of this operation, switches to some other operation, and as soon as the result has been delivered, at some point in time, it will revisit this step and continue the execution of this one. So we wait for the result to appear, and then we do the usual testing. So we expect that the text of the result is this one. and we expect that the result status is 200. And this is just to make this test work at all. And so we should actually execute it. No, it's okay. So the next thing we say, okay, we would like to register something. So we would like to submit some data to our service. Therefore, we create the data. We create the password hash. We create a user data transfer object for Bob. We create an event object and put Bob into that, which is here. And then we do a request on our app, and this time we do a post, and we post to API submit. So this is the URL that we would like to code. And because we have the app, we do not need to have localhost and port number, but we can actually go to the URL, to the parse directly. And then we send the event. So that is how you do a post in this testing framework. Okay. We again wait for the result. So the engine is going to switch to the task, to another task, probably this post task. Execute that one. When that one is done, it switches back to this task, and then it continues, and we just check that this has worked. Okay. Let's have a look into what are we actually calling. And actually to do this, I omitted something that you need to do. I asked you to do this too, you guys. For the next homework, I would like you to have these jest-based testing too. Okay? And to get this, you need to install Jest. You need to add the package, snippet to the package.json, and then you need to restructure your application. And this is in index.ts. This is where our application usually starts. And there were a number of things that we actually doing in index.ts. And at the very end, we were doing this app.listen. App.listen means, so please web service or Express or whatever, please start reading requests from your input port. And what I have moved to another file is all the parts which are defining the routes, so which are the kinds of requests we are going to respond to. And this has been moved to the routes.ts file, which is this one here. So I actually just split the index.ts in two parts, and the first part that is going to be executed is the routes.ts, and this is because if I do this import, it's actually going to, load all these things that are in the routes thing here. So it's executing all these things here. So, and here it is what you probably still know. It is this, please create our web service, tell it to use URL encoded. And I have added this extended true here for some reason. It gave me a warning if it was not there. Tell it to use the JSON body parser so that all the requests are automatically translated to JSON, or the JSON strings are parsed and JSON objects are returned. Use this cross-origin thing, and for everything, that's it, basically. Use support 34,560. And have a submit handler, have a query handler, and here the routes are generated. Add post, API submit, add post, API query. That's the two main things that we use, and this default thing that gives us the welcome. You recall that one. So because we are talking about this, it's pretty common for Express applications to have a dedicated class or thing or file that defines all the routes. Our application uses only two API routes, the API submit and the API query. This is very uncommon, and it's a design decision. And I'm having a big fight with Sebastian Kopay on that because he says, Albert, this is not the standard way to do it. And I say, yeah, but the standard way to do it is dumb. And I don't like the standard way. And so he says, yeah, but the students should know it. And yeah, he's right. So actually be aware that most people actually have multiple posts here, or multiple, actually usually a gets and posts. And they use it. So we have, for example, for the submit, we pass a JSON object telling, oh, I would like to add a new user to my system. I would like to add a new product to my system. I would like to edit a new supplier to my system. I would like to add a new order to my system. And they would have a dedicated route for each of these requests. And I say, okay, yeah, you can do that. But I only have a single request here because it's easier. And the point is, what you actually do implement here is a remote procedure call. Your client does a remote procedure call on your service. And the software engineering is dealing with remote procedure calls. One program invokes an operation on another program for 50 years now. And there has been numerous attempts to really tackle these kinds of things. There was Corba, there were all kinds of ideas how you would actually implement these very efficiently or very well type safe and good, easy to maintain and all these kinds of stuff. So if you have dedicated requests for each of these different kinds of user requests, product, supplier, and so on, you can use the standardized REST or web-based mechanism that you actually usually have. However, then you are restricted to very limited ways what you can pass as a parameter to such a usual GET request or POST request. And so these limited kind of parameters I really hate. So I'm a data modeling guy. And if I'm not able to pass some complex or some structured data as a parameter to my procedure call, I hate it. And actually these REST calls, at least the GET calls that you usually do, are limited to, unstructured plain parameters. You cannot pass complex parameters to these GET requests, and therefore I hate them. That's the whole thing. Probably we will go into more details of that when we do the shop example. Then we could try to have the other alternative, and then we can actually discuss this a little bit further. So for now, we go with this style because I'm the lecturer and I have the power to define that. And we will, but please be aware that this is a design decision that you will need to discuss with your team. When you go on into some team developing a service, you will have to agree on a style here and to find something. And probably when you are the young people that come to such a team, which is doing this for some decades now, they will probably stick with the old style, the old-fashioned style that Sebastian Kopay prefers. And so you need to know about that. Okay, so we do an API submit thing. It was in our tests, and let me, here, no, here, yes, no, yes, no. No. I'm looking for the test. So there it is. So we send to the app submit this complex object here, and then we would like to get a result. So app.submit. So let's go back to roots. So I split these index.ts and roots.ts because the test, too much, it's too fast. Slow down now. Let's go back to the test. The test uses this roots thing only. So it does not do this app.listen thing. App.listen would open the port, and that would be, well, create a conflict when we run our test and we have the server running in parallel. That is one thing that's pretty unhappy. And when the test stops, the port would still be open. And then you rerun the test, and then you have the conflict on the port. And well, there is an option to Jest that tells, oh, please look for open ports and kill them. But well, actually the tutorial says, oh, you better split these things into roots and into the app.listen part in order to have that separate, and do not open the port if you do not need it for the tests. So here we have the app thing, which is actually defined by loading this roots stuff. And so we are able to do this get call and to do this post call here. And let's have a look again what is happening when we do this post call. We go for the submit handler. Yeah, well, actually we go for, sorry. It's such a long time that I did this, roots. Here says, if there's a submit query coming in or submit post coming in, go for submit handler and handle it. So we need to go for the submit handler. And there he does the handle. And the submit handler has a set of handlers. And we now do the dispatch. So there is different queries coming in, and then we need to decide which one would we like to call, and therefore we set up these handlers thing here, which is a map, a hash map, where we can ask with a key for a model command handler. Okay. How do I go back? Here, yeah. So we set up this table and say if it's a request that has topic users, we use the user command handler. If it's a request that is concerned with suppliers, we go for the supplier command handler. For products, we go for the product command handler. So the user command handler, and actually the handle thing here says, okay, handler, take the event topic, get the handler that is going to handle it and call handle on that one. So we will probably run into the user command handler, and the user command handler has the handle method, does some things and handles these requests after all. And before we go into that, I'm now ready to go for my slides again. And we need to go into the event storming again a little bit more. I have refactored this page. I'm going to zoom into it soon. I just would like to, well, give you first an overview. And, well, actually, we need to zoom one time. So we have this top line. This is what we started with. At this top line, we were identifying user events. And I have added a little bit some description on what's actually going on in this lane here. And the top level lane is actually defining something which is called usually the business process. And it's dealing with so-called domain events. So what we have here is something like Bob has registered to our system. Bob orders a pallet of shoes. Italy delivers the shoes. Carly stores the shoes in our warehouse. And Dora puts the shoes into the shop, and so on and so on. This is at the very high level of abstraction, dealing with our business. So what are the main steps that are running in our enterprise, in our overall application, in the overall system? And then we are going to split this into smaller details. So actually the event storming says, for each domain event, you explain who is actually triggering this, that this is going to happen. So Bob registers, or actually these orange stickers say there's something that has happened, Bob has registered, and then you ask for each of these events, so how did this happen? Who initiates it? So why is this happening? And there are 2 or 3 different reasons why is this something going to happen on the business level, because some people do initiate something. So then there is a graphical user interface where you can actually start some operation. And that's what we have dealing with so far. There might be a timer. So saying, oh, we do it once a week. We create a report for the management or sum up all of our sales or something like that. Or there may be some other event. So this event is triggered by a previous event. That something has been happened, so an invoice came in or something like that. So we trigger the payment process. So in addition, then we go into each of these events and say, okay, if it is has a user interface that triggers this, how is this usage of this user interface actually doing that? And so we go into something which I would like to call a distributed workflow. So this is a new notion I would like to introduce today. And the distributed workflow is actually saying that they have something where software systems are working together, but there's more than one program. There are multiple programs. In our case, it's the user interface that runs in the browser, so the React client, and the backend service. So there are 2 of those, and then they work together. And in order to get this right, you really need to think about who is doing what at which point in time. So these 2 programs are inherently running in parallel. And so you need to know how is actually the timing and how is the collaboration and the message passing between those 2 programs actually working. And therefore, I would like to really, put this down into, multiple lanes after all. And I will just go for something like that. No, need a more an overview. I have split this in 2, there are 2 programs in our example that are collaborating, and for each program I have 2 levels of abstraction. I have workflow events that are the events that are actually occurring in a single program and that are sent over to the other program. And I have model edits. This is where we actually have another layer of abstraction where we deal with complex data at within our program. And what I really would like to get across today is that each of our participating services or programs or clients has these 2 layers. One layer where it deals with the workflow events, and one layer where it manages its complex internal object model, data model. So, and between those, we have an exchange of events. And let's dig into this again. So, This is Bob in the warehouse browser, and he just do the register thing or the login thing. So we have an initial screen at 1 o'clock, and he's in the enter URL. And so this is the React user interface. Can you actually read that, or should it be enlarged? Is this okay? Alexander, can you raise hand? Yeah, okay, cool. So there is this thing, you enter your email address, you press OK. And this is what's happening at the workflow in our application. And below this workflow, there is our current data model of the application, of the client in this case. And actually, this is just the start, so the client has not yet any data. So now the client needs to know whether Bob is already registered or Bob is a new user. Therefore, at 1:02, we sent a request for users. And this is, a new kind of errors I have actually found in my application. And this says I sent such a query, API query with topic users to my web server. Here is the warehouse service. So this is, the person or the system or the service that's actually working. Here it was Bob with his client in the browser. Here is the other program, the warehouse service. And the warehouse service has no graphical user interface, but it has these command handlers. And so what we actually get when we get this query, we see, okay, it is asking for users events. We have a list of users that is, we know from earlier programming runs. So we already know about Kali and Dora. Can you read that? Kali and Dora? Okay. And so we send back this list of events. So here sending, we do events. And these events are actually handled at this level here. And after that, the data model at our client side knows about Kali and Dora. And so these are all the users that are already registered in the system. And because Bob is not yet known in the set of all these users, we say, okay, Bob needs to register now. So we go for the register page. We get all the credentials of Bob, send an OK. The handling of this OK button adds this data to our local data model. So Bob is now in the data of our client. And in addition, it sends the data of Bob to the server. The server said, oh, there comes a user, a new data request, and this is going to the submit API. And so it adds Bob to the data which is known on the server. So at 13:03, the server did know only Kali and Dora, and at 13:07, he knows Kali, Dora, and Bob, or it knows Kali, Dora, and Bob. And you really need to get this image in your head right. So at which point of time does which of the participating program know about, have which state of data? That's a very important thing to get right. Okay, and so this is the registration process. I have done the same thing for the other things here. So this is the same thing for products. So we are in this user interface. Bob is logged in. He's on the main page. He clicks products. And then we go for currently, what is our data? We actually have Bob, perhaps Kali and Dora, but we do not yet have product data. So we do send a query to the service, and the service already has, for example, the China LEDs, the light emitting devices, or diode, it's actually. So we send the list of already known products back to our client. The client handles this event, adds it to the data, and then we can go for the main products page. And then we see, okay, this is the product we already know about. And then we click for add in order to go into more details. We add the details of the cool shoes product, and we put it into our own data, and we send the shoes event to our service. The service calls the handle product shoes, adds the shoes to its internal data, and then we go back to the products page, and the edits here is totally wrong, and I need to change that. Okay, and the cool thing is I can do it online. So we go back to the main products page, and there we show now the list of all the products that we currently know. And here's some point that we are running this client that Bob is working on concurrently to clients where Carly or Dora or Fred are working on. So while Bob were adding cool shoes, other people may have added other products to our system. And we would like to show here all the products that are known at the server side. So after adding the shoes thing here, we are sending a new products request to our service, get the list of known products, including the shoes that we already know about and the LED we already know about. So we get the current list back. And if Carly has added a shirt, meanwhile, that would be in this list too. And so if the service knows about more products, then we could get them now. And so we would actually list them here on the main products page. And that's an important thing to have in mind too, that there are more people working on that. So for completeness, I have done the same thing with orders. And actually the orders, that is the thing that we are going to implement today. And I will try again to show you how to implement this thing, and I hope I get the test running today. And I have lost my smartphone, so I lost the time. Okay. And if you do not if you are not able to finish this in time today, I will stop at some point that we run out of time. I will try to avoid to go into much overtime. If I run into overtime, then it's actually too much that does not fit into a single lecture. And I'm promised to myself as a thing that I will change in the new year, that I slow down the pace of this lecture here in order to facilitate for you to follow, and because if I'm running out of time, I'm probably telling too much in a single week. And we have more time and we do not need to hurry. And I would like to really go into the details and explain the rationales behind that very, very precisely, rather than to rush through the things and you don't get the idea. So that is what we are going to implement today. And it will start that we go for the orders, and then we check our local data. And then we first update our local data, whether somebody has added orders in parallel, some other people. So we send an orders request to the service. So here is the warehouse service. And then the service looks into its internal data, and we assume that Eric has already, added 100 LEDs to our warehouse. And so we would like to send this order that Eric has done back to our client, and then the client shall actually show that if you go for the orders page that there is already an entry. Okay, and this is what we are going to implement today. And therefore we actually will start with a test, with a jest test. And because what we actually need to do first is we need to register this order that has been done by Eric. So last time before Christmas, when we added the products to our system, I was really starting in the Cypress test. And then I was doing this very first thing in the Cypress test was pre-register a good old product. And yeah, we might do that. However, the Cypress test has difficulties in accessing the internals of our service. And so it's much better to do this very first step, pre-register the order of Eric in a jest test. So we do it in a jest test today. So we go for tests. Let's close this one. Let's close this one. So it's more not that crowded. And then we go for a new file and we call it orders test ts. Okay. And close that one, close that one, close that one, close that one. And we would like to, well, we copy paste a lot of things from the product tests because it's easier. So what we first need is this describe thing here. Describe. Hey, that's cool. And this is a method call having two parameters. And the very first one is, what are we describing? Warehouse ordering. And then one gets an operation as a parameter. Where all these it stuff is in it. And just have a look at it. Yeah, no, I think here it's cool. So let's do the first it. And actually, I would like to copy this one. The first it is just say, can I actually access the service? Is it the service there? If you don't get that one started, we can actually stop the whole thing. And okay, so if we get, I think, so it says I do not have a request. And probably we need to import that one, or we do not have an app after all. So let's import the app and the request. So we have a receiver test thing, that is where the request comes from, and we have the app that is from our application, and then we do this get, and that should actually do the job. And so let's execute that. And I actually have yarn run test. That is how I do that. Let's have a look into package.json. Scripts. Test is doing calling jest with this detect open handles, which would close a port if we actually would open one, but we do not do that. So we could actually forget about that, but let's do jest. Okay, if we execute that, and I would like to debug that, start debugging. It's running a whole bunch of tests and says everything is runs. No, it runs, it parses. So it's passing user management, it's passing suppliers test, it's passing products test, and it's passing the orders test. Our test is working. That's cool. I don't trust it. Let's change the test. So on the first run, a test should always fail. And it's not a good idea when it runs automatically and doesn't fail. Yeah, it was failing. The other things are still executing. And it says failing, orders test. It says welcome my, it should be welcome audience. And it's happened in order test. And you can control click on it. And here, this one is the test that was failing. So cool. That's what I was looking for. Seems to work. Just rerun it. Great. Okay, now it works. So what is the next thing that we would like to do? The next thing, if you go for the product test again, is we register an order that already exists. And I just copy the whole thing here, go for the order test. How do I format? It's Shift Alt F. Yeah, Shift or Alternative and F. Here we go. We register Eric orders 100 LED. So, and it starts with a product DPO. That's not what we want now. What we send is an order DTO. And we need to, well, implement that still. And that will need some data that we do not yet have. And then we will do an edit, and the topic will be orders. And there will be an ID and the other stuff. And the user is Jest. And the payload will be an LED. No, it will be the order. Order. Okay. So recall, the DTOs are the payload that we are actually sending around. That's the description of our model data. And every different kind of model data that we are sending around is wrapped into an event. And that is the two layers actually that we are dealing with. And so an event has always a topic, an ID, a date, a user, something like a state, and then the actual data. We will later on actually extend this type again, but basically that's what we need to do. So it says no, events do not have a topic. That is because we need to import the event. There are multiple event types and it uses the wrong one. So we need to import events, and that comes from my local thing here. And actually, Sebastian hates it if these are double quotes. It should be single quotes. And so, yeah, I will change that up there later on. So now we have event, and the events have a topic. That's cool. However, we do not yet have an order DTO. Let's go for... I slightly have reorganized my files. I have a business model now and the data model or plain model here. The business model has all these command handlers, submit handlers, and query handlers. And the model has the editors. So all the changing of data model are going through a so-called editor. And the root of this is the model editor. And here we do also have the product type and the user type and the supplier type and these kinds of stuff. And so what I'm going to do is I take this product type and copy and paste it and rename it to orders and say, okay, in the orders, I have oh no, that's a bad idea. Let's remove it, move to the recycle bin, and we will just copy the orders from the web warehouse. There's the source, there's the model, and there's orders, and that's pretty much the same thing that we need. And again, this is a serious design decision. Let me copy that. Go down for our model here and insert it here. So now I have it. And let's get rid of this one here. There's the order test. That one needs to import the order DTO, and it should now be able to do so. And it says go for source model. No, it is ... model order, and the double quote should go away. So now we have an order DTO. That's cool. And let's have a short discussion on, we have two copies of our data. We have data at the client side for users, products, suppliers, orders, and this kind of stuff. And we have similar data at the server side. Usually, software engineering has the golden rule, do not repeat yourself. So you should never, program the same thing twice. So there should not be two files that define how an order DTO looks like. In software engineering, you never do that. And here, Microservices says, yeah, you do that. Microservices says, if there are two independent microservices or programs that share some common data, each of the two programs should do its own definition. They should not actually have a common library, a common source code file where they get these definitions from. And this has to do with team organization. So it's a pretty new idea that came with microservices, saying, no, we duplicate that. And the reason for that is that usually there is one team of developers that is working on one service. So there would be one team working on the user interface thing on the client side, and another team working on the server side. And these are independent teams. And if these are two teams, they would like to deliver new versions of their software independent of each other. And that's very hard if you have such a shared library that is going, and you want to do a change to that shared library. Then both people have to agree on when are we going to do the change, when do we adapt our microservice to these changed interfaces and these kinds of stuff. And in order to decouple those two teams of developers and the release cycles of those two teams, microservices propose to copy the data structure. And this actually will allow us to go for the order that we are running in our, this is the web warehouse. No, I don't want that one. And the order that's in our model, in our service, we can actually change them independently. Well, to be honest, we should agree on the DTO, because that is part of the event that is going to send from one program to the other, and they should really have the same idea on how this DTO looks like. However, the order itself is something which is totally internal to myself, and I can actually extend this, modify this, change the attribute types, and anything that I would like to do. All I have to do is, when I get an DTO, I need to be able to, well, create my order and have this internally. And we will actually, through the course of this lecture, later on really do that. That the server side stores more information about an order than the client side. And therefore it's very well handy that they each have their own copy of the type definition, so they are able to, well, extend these copies independently. And on the other hand, on the other side of the coin is where we still need to, well, agree on the DTO. And there is some flexibility here too that will be discussed during the course, but we are really restricted here. And actually, if we would like to, well, restructure this DTO dramatically, then we need to start to think about versioning. So that what we would actually do is we would add something like a version tag to this DTO thing here and say, okay, these DTO comes in, well, version 1 or no version, then it is the original one, or version 2, which is completely different structure, and then a new type. And then there needs to be something like a flag that tells you, oh, I'm dealing with this DTO or with that DTO. And there are, well, strategies to deal with this. And we hopefully will be able to cover these strategies during the lectures or during this course. And so far we are now, the long story is, for now, just copy it from one program to the other. Although software engineering says, do not repeat yourself, microservices say, oh yes, please repeat between teams. Every team repeats all the steps. So now we have the order test. That one says, oh, you need to fill a lot of things here. We need an ID. So what do? We need, as an ID for an order, we usually take something, unique number. So for products, we have a barcode. For suppliers, we have an email address. For orders, well, we could take the email address of Eric, who is doing this order. But if Eric does 2 orders, we need something in addition. And well, if you do not have any other idea, you can actually generate a unique, universally unique ID, a UUID. That is just a pretty long random number. And this random number is that long that it is very unlikely that any computer in the world is going to generate a number that has been already generated by any other computer in the world through the whole time. So it never happens. The random numbers, they use a random number that is longer than they could actually give a UUID to any atom in the universe, and you still have random numbers at hand. So it's several order of magnitudes more than the number of atoms in the universe, and therefore you have plenty of those. And you will never create a conflict. Well, actually, I do not like UUIDs because they are so long. And it's hard for a human to read them and to distinguish them. So if you have a list with some 100 unique IDs and you spot for a certain one, you're pretty bad doing, or have a hard time doing it. So I usually use a timestamp. So this is an order, dot, just to say this kind of ID begins with an O, and then it comes with a timestamp, and timestamps are always in ISO format. So it's 2021, so it's 01 for January, it's 04 Do we have the fourth? Yeah. It's a T, and then it's 1310. Some seconds, and then you should add milliseconds, 001, and a Z. That means we are referring to Zulu time or to zero time or zero offset time. This is Greenwich Mean Time. Be aware that your program may be used on several parts of the world that are running in different time zones, and then logging timestamps with local time zones, something get you in a lot of trouble. And because this is going to be logged in our database, we always use Greenwich Mean Time. If you show such data to your user, then you may apply a locale, but internally, please always use Greenwich Mean Time. It's my style of things doing it. Okay. And we need a product that is going to be ordered. And for the product, we use the product ID, and that was a barcode. And we used for now P40 for the shoes. So I'd use this barcode here. And this is a string. And then an amount. So how many units are we ordering of this? It was 100. And we need, what else? ID product, a supplier. So where do we order that? So the supplier for this was shoes at, come on, it needs a quote. Shoes at Italy, at Rome.Italy. Okay. And there needs to be a comma. There is amount. So we have an ID, we have a product, a supplier, amount, and a state. And I think there's something missing here. The user who is actually doing it, who is doing the order, but this will be part of the event, so we can omit it from the order. Okay, so we are fine. State. So why has it state? We have discussed that the state might be copied between we have a state in the event, so probably we do not need a state in the order. And for the product, I didn't do that. Here is there, let's have it for now. I'm not sure about that. Come on. So why does it? State is, well, initial. Okay, here we are. So the topic is orders. The ID of our event is the same as the ID of our order. That's a convention that we use, and we stick for it for now. And that makes a lot of things very easy to get from event to the object and from the object to the corresponding event. And we usually do this via the ID. We have a date, users just, the state is just created, the payload is the order. Yeah, that looks fine for me. So we have now constructed an event for a new order that we would like to have in our service. So we do a AP submit and send the event and ask for it to have the request to be 200. Let's try it. One failed. Yeah, so it was 500. It didn't respond to our request. Let's look why. So we need to go for the business model and therefore the submit handler. This was the one we were asking for. And then we see, we have command handlers for users, suppliers, and products, but not for orders yet. And here, this one is going to deliver a null. And so this one is going to throw a null pointer exception. This will be, caught or trapped or interfered by the surrounding thing, and then delivers a request to return 500. Okay, so it didn't work. Damn it. So we need to do that. We need a command handler for orders. And it should be an order command handler. So we do not yet have it. So we copy it from the product command handler. And it should be order command handler here. Okay, so we need to do a lot of changes here. So it should be order command handler. Fine. I would like to get rid of this in here, or just, yeah. And that one, go away. Yeah, fine. Order command handler, constructor, yeah, fine for me. Handle event, yeah. Get, yeah. So what we go for is we ask for the event history with this topic and the idea. We look for an old event that is providing data for the same order. And if we have an old event, then we look for, there are two events that say I would like to have an order for shoes. Which one is the valid one? And we actually do here a strategy which is called last edit wins. So if two people independently create an order with the same timestamp, which is rarely happening, then we will take the latter. How do we identify the latter? The event has a timestamp too. And then we can actually exchange it. If we get two events with the same order ID and the same timestamp, we say, we received the event twice. And then we say, we already know about it, then we are done with it. Okay? And this is what more or less is happening here. If there is old events on that topic and that ID, then we say, give me there might be multiple edits on the same order ID. Okay, I asked for the latest of those, that is the old event. Asked for the date, and if the date of the old event is greater or equal of the date of the new event, I say, this event received, I have handled before and I have a newer event, and so I'm ignoring the old one. So then I access the payload, which is an order DTO, which I need to import. Okay. And then I need to deal with these things at the right level. So I'm here. And so our order, I do have orders, yes. is going through multiple states. And the order is going to be created at the client side. And then we usually register it at the server side. And later on, this order will be doing more things. So the goods will be delivered to our warehouse, and then the order changes its state to delivered. And actually we will have delivered at client because somebody is doing this in his browser or her browser, and then this information delivered is going to the server, and so we will have delivered at server or deliver at registry or whatever, so that we already know that we encode into this event state or into the order state. How is the business workflow that deals with this order, the distributed workflow that deals with this order, how far did we actually go through it? So which part did we already achieve? And that's pretty important that each of the applications knows where in the workflow are we currently. And so what our code is actually doing here is checking. So I have to handle some new state or information about some order, and it might be that another step has been achieved in the distributed workflow. And so we check for if the state is created, we do something, or if the state is removed, we do something, or the state is delivered at client, we do something, and so on and so on. And usually if some event is happening at the client side, we send that event over to the server side. Then at the server side, we will react to this event by doing a new step. So events happening are driving my distributed workflow. The distributed workflow is what's happening in this thing here. So we have a flow of information, a distributed workflow going here, and whenever I receive an event at the server side, I say, okay, something has happened at the client side, and I do react to this by answering a query or by raising a new event, by switching the state of my workflow forward. And so this thing of, switching the state of a workflow forward, it's also called a Saga. In the distributed workflow book, in this book, they call it a Saga, and they also propose to implement this with such if and else or switch case statements where you say, okay, if you are in that state of your Saga, of your distributed workflow, then this is the next thing that you need to do. This is again something which is a design decision that needs to be discussed in depth. There are multiple ideas how you could do that, and actually object-oriented design usually avoids something like a chain of if-then-else statements. You should not have it. And there is a number of design patterns that help you to avoid these kinds of things. And you should actually deploy a state pattern whenever you see something like if state equals A, B, C, D, do something. And if you go for the design pattern lecture on this state pattern, it actually says that apply the state pattern and you do a very complex design here only if you expect your state chart to change frequently. And if it is pretty complex. And if you do expect that, you can actually do it. For now and for this lecture, we stick with this if then else chain here because usually our state charts are not going to be very complicated. And actually, there is an alternative to these complicated state chains that have, so if this chain becomes too long, we will probably switch to a new object. So we have this order here. The order has been created, it has been registered. Some good is delivered. The good is stored into our warehouse. The good is done into the shop. Then some of the goods on this palette of things is sold to some customer. And so we do not only have 99 LEDs left or shoes left. And then the whole things are sold out. And then the palette is returned to the vendor and these kinds of stuff. So there is a pretty long chain of things that's going on in the future. However, we can split up this chain by dividing it onto multiple objects. So as soon as a palette of shoes has arrived at our warehouse, we say, I consider this order as completed. Just handle the payment and then forget about the order object, and we now deal with the palette object. And the palette object has additional properties, like I'm stored at position B2 in my warehouse, at a certain shelf, at a certain board in my shelf, or a certain position where you could actually put a pallet into. And because this is information that is relevant for a pallet in order to find it later on, but it's not really relevant for the order where I handle the delivery with the vendor that supplies me with the shoes. Where I stored this thing is not part of the ordering process. And so I can split this whole workflow into chunks that are of of small size, and then I can actually have very small, simple state charts by distributing them on multiple objects. That's the idea. And then I deal with the complexity of it. And because I keep my state charts that are or final state machines that I attach to the order very small, I do not need a fancy design pattern to implement it. Yeah, that's a good point here. Okay. There's some additional thing we need to discuss again. Yeah. So, if it is just created, the order, I would like to have it in my server-side data model too. And that we will do today, and then we will finish for today. And there's, again, design decisions to be done. So what you usually have, your submit handler has a model editor. And we go for the model editor. And I have refactored this model editor. Before that, it has something like all these things that is now in the users editor. It has a map of users. Have operations like get all users, have a new user, remove a user, have a user DTO, or create a user DTO from a user, do a get or create user, do a get from users. You recall those, hopefully. And actually, come on. We have had introduced already the main editor. And the main editor currently has suppliers and products. And for the products, it has a have product. For suppliers, it has a have suppliers, and so on and so on. And I was tempted to add the orders to this main thing here and have in the main editor now also a map of orders and these kinds of stuff. And I then decided, oh no, that's not a good idea. Because this now becomes a very crowded class, this main editor. And therefore I said, oh no, I split them up. I have multiple editors, one per event type. And so we will actually not do it in the main editor, but we will have an orders editor here. And that one needs to be initialized. And it still needs to be implemented. And I just copy the users editor and turn it into an orders editor. And go away. No. Here's the users editor. I copy it and turn it into an orders editor. So and now we do a lot of renaming things here. So it's now an orders editor, and it has a set of orders, a map of orders after all, and the get all orders, order. And we should do a search and replace. But I'm actually, whenever you do just a search and replace, it fails. Let's go for it, although it takes its time. Have order. It's order DTO. Yeah. Yeah, but won't that refactor actually the actual user type too through this import? Yeah. So let's have an order here. And oh yeah, it has already imported it. We can have a copy paste here. Ah, damn it. Copy. Damn it. Copy, copy, copy. Order. Order. So that one should be order DTO. Yeah, I will become faster. And that one should be, then we can do this order thing. And now he says, oh, we do not have a get or create user. I can actually rename that one. And it should be an order DTO ID. Okay. And then one that fills it with all the details. Let's do it line by line. So we have a new order. And that one gets an ID, which becomes the order DTO.ID. Is this a good way to do that? I have no idea. Order.product. Yeah, that's a good way to do that. We need a product. And there's a problem here. We don't have access to a product. So we need to do a get or create on the product thing. And what is the time? We have 5 minutes overdue. yeah, let's do this have order thing and then we stop. And then we continue next week. Order.product thing. Yeah. So in order to do a product, what we need to do is something like main editor and then get or create order. No, product. We are looking for a product. The problem is we do not have a main editor. And so we usually get it via the model editor. So, however, we do not have a model editor. So we need this dot model editor. And somebody needs to provide us with this thing here. And therefore the orders editor should have why not private model editor? Of type model editor. And, well, yeah, it needs to be initialized. So we need a constructor. How do you... Yep. And that one needs a parameter, which is again a model editor. Of type model editor. You say, if I say private here, I can omit that line of code. I hate it. I find it confusing. So no, I really need a list of attributes in the class. No, I can't do that. Kids, don't try that at home. No, never do that. Do not listen to Sebastian. So, once we create the orders editor, we actually need to pass this as a parameter. So, orders editor has not been yet imported. New, so why there is this dot here? Great. Okay, so we need to pass the model editor because the order editor wants access to the main editor. And probably, so the main editor so far did not need it because the product has no reference to some other thing and the supplier neither do. And therefore it suffices this way. Okay, and then we should actually do the initialization. This dot model editor becomes model editor. Okay, and then we can do this model editor main editor, but no get or create product. So why not? It wants the barcode as a parameter. And so we need to the order DTO dot product thing to pass as a parameter. And that one has no, the order DTO is not of type order, it's an order DTO. Come on. They are almost there. Okay. So, one more. But we are not yet done here. So we need more stuff. Let's complete the have order and then we are done for today. Order dot supplier becomes this dot model editor dot main editor dot get from suppliers. Get or create supplier with order DTO dot supplier. So that should be the email address of that supplier. And then we can look up the list of our suppliers. If you already have it, then it gets delivered to us. If we do not yet have it, it is created and added, and then we are done. And so we need an amount. Come on. Order dot amount becomes this. No. Our order DTO dot amount. Fine. State. Let's take it from the order DTO. We could also say, oh no, we have the new state, but I'm not sure about the state at the order. I probably will drop it next week. It shouldn't have a state at the event and a state at the order. I'm not sure about it. And if we do not need it, so why do we do that? No idea. It's good enough. So I probably will drop it, but I have to think about it. Okay, fine. So we have created the order, fine, but it's not yet done. The have order thing needs to add. Oh, the get or create order should have done that one. So we do not need this line. Yeah, we just fill the other attributes and we are done. Cool. Hey, that one is good. Perhaps we should fix this one too, but I promise to stop for now. So, wrap up. We did the jest thing, and we are still in the middle of testing the new order thing, and we spent quite some more time into that one. The good point is, so far my tests are running, and the bad point is, well, actually not. The submit new data did not yet work, but it's a lot of things that we do at the server side to deal with this new kind of events, and therefore we need to do a lot of things. So this assignment is still, well, not yet ready. So we need to go through the rest of these things in order to get the orders done. And so I just postpone assignment number 6 for another week. Prepare. Next week, I hopefully will be able to complete these things here. And then there is this big assignment still open there. You actually complete the whole thing. This part and this part, so that it's fully working. So that you have the full user interface for registering users, logging, for suppliers, for products, for orders, and the full connection to the warehouse and the full data model at the warehouse side and the full handling on the warehouse side and the full exchange between those two. So that we can actually stop with these two here, and then we will have the week after that the event store for the warehouse. And then once we have done this column here, that one is pretty similar. And so you will do the most of these things as homeworks, and I'm not going to show you every detail of that, but I just give you an assignment, so how I think it should look like, and then you are able to implement it yourself. Perhaps we do some of these scenarios that I have shown you in the event storming together and then you just go for these scenarios and then implement them on yourselves. You do not need help for them by me. And well, there's some more that is going to be happening at the warehouse, where actually the supply arrives. I'm not sure well how we do that. Probably that will be another homework too. Because we will need 1 or 2 weeks to get the event store right, and then we can have this together. Okay, so not ready for a new homework completely, but if you feel confident on how you would like to implement stuff, you can already start working on this assignment. It will be due Thursday next week. So because there is no real assignment today, there will be no Discord session on Thursday, because there's nothing that you actually need to show to us. However, if you have something that you already would like to show to us, some old stuff you would like to show to us, hopefully there will be some people there on Thursday that you can show, well, pending old assignments, so that you can catch up with the course. Well, sorry for, again, not completing this, but I'm proud of myself for not hassling through it, but give it the time it needs. I hope it was interesting for you and you learned something, and we see you again next Monday for the rest of the orders. Thank you for your attention. Give me some cheers, come on. Okay, I'll stop the recording.